Hello, everyone. Welcome to our webinar. We will start in 2 minutes. I'm waiting my presenter, Hein Kun. Hi, Hein.
Thank you.
Everyone, from a hot sunny day in Turkey. I'll be joining you from Turkey. And thank you, everyone, for joining our webinar. Today's webinar will be about IoT connectivity, IoT data connectivity, and the differences between APN, prepaid, and roaming. I will be your host. My name is Işıl Sümer, and I am the marketing manager of Flexibit. I'm based in Netherlands, but I'm here in Turkey to visit my family. And our speaker will be Hein Kun, the executive director of Flexibit. Hi, Hein. How are you today?
Good, thanks. Cold and rainy Cape Town. I wish I was in Turkey now, but hey.
Always sunny here, right? But you'll be like in sunny days in September or October soon.
Yeah, absolutely.
Yeah, perfect. So just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel, and I'll bring them up during the presentation, and we will also have time for questions at the end. Now, without further ado, we will turn the time over to presenter Hein.
Thank you, Sil. Thanks for the intro. Yeah, welcome everyone. Quite a broad topic to cover today. I'm not going to get too technical, but I thought the idea today is to really talk about different IoT connectivity options, and specifically also looking at the cellular IoT space in terms of different options, pros and cons of various ways of connecting devices. Yeah, so thanks for joining us. Agenda, we're going to have a quick chat about what IoT connectivity is. We're going to talk about the different types, and then I'm going to talk about choosing SIM types and choosing networks. And then also I will leave enough time at the end for questions. So as Ishil mentioned, please post questions in the GoToWebinar app, and we will try and get to most of them at the end. Right, you know who I am. Quick note on our story. Basically, FlexSwitch has been involved in IoT connectivity for over 10 years. We've seen various IoT projects being rolled out across Africa and also into the rest of the world. We've probably seen the good, the bad, and the ugly in terms of IoT projects. And yes, there are various reasons why IoT projects fail. Typically, it sort of falls into a few categories. Firstly, either from a technology perspective, some bad decisions around technology. Now, that's a very broad statement, but it could be anything from sensor level right up to sort of platform level. Secondly, we've seen some projects fail around business cases, basically costs, and basically companies underestimating the cost of some of the projects and where it doesn't fit into the business case. Thirdly, one of the reasons why we've seen projects failed, and this is one that is often overlooked, is that the people side, the people and change management side. It's one thing to implement technology into a company or industry, but the effects that it have on people, and the fact that we've now got ways to do real-time information on people and what they do and everything, sometimes leads to some interesting people issues. So that's the third sort of one that we've seen. And then lastly, what we're going to talk about today is really around looking at connectivity issues, and yes, choosing the wrong connectivity issue could be one of the reasons why an IoT project fails. So it is an important one, and it's also one that is sometimes overlooked. I think a lot of time is spent on the whole end-to-end solution, and with the intention of just sort of sorting out connectivity right at the end. That's the easy part. We'll just pop in a SIM and ship the device. And especially when one is more inexperienced in this field, you don't always realize that is quite an important decision to make. And that's what we're here to talk about today. The industries that we typically work with in the IoT space is pretty broad. I'm sure most of you have sort of understand how IoT functions in most of these, but it really is broad and it's expanding. Some of the sort of growth sectors that we've seen, let's say the last year or two, definitely agriculture. There's really a lot of IoT applications that are being deployed in that field. Energy and water still remains a big sector. Security is as relevant as ever. A lot of security technology being deployed. And then also in the fintech sort of point of sale type space, we're seeing a lot of activity. So it's quite exciting that some of these sectors are really starting to see not just conceptually, but actual deployments, solutions that are maturing slightly, that are moving over out of sort of POC phase. And I think a lot of the growth is being driven by demand in those sectors. Yeah, we're quite excited about the IoT space, specifically in Africa, and we're seeing constant growth in this space. But the applications here are pretty broad, and today I'm not going to focus on one specific application or industry. I'm going to talk quite broadly around IoT connectivity and the different options. So just where we sort of fit in and what we're talking about today, when you're looking at the end-to-end development of an IoT solution, there's so many decisions to make from the one side, from sort of sensor, gateway, router, device level, then into sort of firmware, and then from the other side, in terms of database, apps, processing, decisioning, and dashboards, the software side of things. And connectivity is sort of the glue that where these two worlds meet. And often those, in terms of IoT solutions, the knowledge in the team that are deploying are either typically more on the software side or more on the hardware side. But from whichever angle you are coming, connectivity still remains a very important part of the solution. And as I mentioned before, if you don't get this right, it could lead to some serious problems. It's also not easy to go back and change. A bit like hardware, once you've sort of chosen your option, it's not easy to reverse engineer. It's not easy to go on site and change things. So it's quite an important decision that is part, that needs to be a part of the hardware and software architecture, and that needs to be tested properly before deploying. It's also sometimes, as I mentioned, a bit of a rushed decision, and this is where we sometimes come in. Sometimes we get approached really last minute to look at different connectivity options, and that's fine. Usually you can still make a good decision, but obviously the more time you have to try different options, the better. So there are many types of IoT connectivity. If we start at the sort of licensed part of the equation, there you have your normal 2G to 5G sort of GSM type spectrums. What is important when you're looking at that type of connectivity is to make sure that you choose the correct hardware modules and modems. A lot of discussions at the moment around what mix of modem and modules people should be rolling out. It adds a cost. So sometimes if the costs allowed, you can cater for a wide range of spectrum options, but often the cost, it's very cost sensitive when rolling out IoT devices in terms of module costs. And the question that often comes up here is all around lifespan of specific spectrums and 2G and 3G sunsets and LTE and NB-IoT sunrises, if I can put it that way, or new spectrums that are coming online. And you always have this debate between sort of future-proofing, what was going to be switched off at some stage versus having availability to switch to newer technologies and spectrums. The one question we are getting quite a lot at the moment is all around 2G and 3G switch off dates. There is some information around it from networks. It's not something that is publicized very widely, but yes, these are sort of decisions that you need to make when you are looking at connectivity options, to make that in conjunction with your hardware options that you have. Just on that, 2G interim switch off date, MTN, we haven't had any formal communication. The last communication around Vodacom is 3G switch off to start in 2023 and 2G switch off to start in 2025. And what we expect in the meantime would be a squeezing of those spectrums as it's quite valuable. So yes, these are all decisions that you need to make when sort of selecting different device and modem options. That's on the cellular side. Yeah, then we've got on the low power LPWAN side, so low power type spectrums, there are sort of two players, three really, in the unlicensed spectrum. LoRa is a connectivity option more suited towards non-critical applications. I'm seeing quite a lot of that in the sort of agri space, where you can set up your own networks wherever you need to. There's definitely a place for that, quite low cost. Then Sigfox is the other low power technology that started to get a bit of traction. Unfortunately, the local Sigfox agent SquidNet have decided to withdraw, as it is not viable as a business model. So yeah, there's lots of uncertainty around that at the moment and the future of that. And then the other LPWAN or low power option is the NB-IoT option, and here this operates in the LTE spectrum of mobile operators, still in sort of semi-launched beta phase. It hasn't been rolled out nationally yet. Vodacom is the first network in South Africa to roll that out. They've got about 3,500 base stations live. Apparently that covers roughly 65% of the population. And then also Safaricom in Kenya have rolled out a NB-IoT network. So yeah, that is what we expect. A lot of the 2G devices currently, the new generation of those devices would look at either having the option for NB-IoT or LTE connectivity as a future-proofing strategy. And then, yeah, satellite communication is the other option. The older generation satellite offerings, as well as the new generation low orbit type of connectivity. Yeah, it is an option. It's not always suited for IoT. The costs related to that and latency issues could be an issue. But again, these are just all different options that you have when looking at IoT projects. And yeah, it could be quite a minefield in terms of weighing up pros and cons around all of these, as well as risks and costs. So yeah, today I'm going to focus a bit more, delve into the cellular connectivity space, which is the area that we particularly focus on. And yeah, it's interesting to see a report that came out last week to look at the sort of growth in IoT, cellular IoT subscriptions. Global increase of 12% during 2020, up to 1.7 billion connections. Overall, globally, it's plus minus 18% of all mobile SIM cards. But just a caveat here that a very large percentage of that is in the China region. So if you look at different regions, the percentage goes down to 1 or 2% in most countries. But there's still good growth here. We expect some more in future. Okay, so I'm going to delve a bit into different SIM types now. I think we're getting to the nitty-gritty now. And here I want to talk about 4 different SIM types, general SIM types that you have as options when you're looking at cellular IoT connectivity. And these are all options to consider. Just to make the point that I made at the bottom there, that typically no single SIM is the best for every single deployment. So there's no magic SIM that ticks all the boxes. And over time, we find that a lot of IoT companies will end up with a mix of SIMs, a type of SIMs, as well as a mix of networks, just because, you know, rolling out different solutions might require different types of SIMs due to the nature of the application. So I'm going to kick off with business prepaid and then work my way through to the global roaming. So business prepaid is a very sort of flexible way of deploying devices. It allows for automated SIM monitoring and recharging. It runs on the public APN, and oftentimes when I hear people in sort of from an engineering perspective or IoT perspective hear public APN, I get a bit of a smirk around, you know, ooh, that's for the public. Not really. It's actually an incredibly robust and reliable APN. You know, the chances that an entire network goes down is incredible, is far less than, you know, having issues on a specific APN. So, you know, we've found a lot of solutions that are rolling out on the public APN space. Also because we find that a lot of security is now moving towards the device and encryption. You know, the old days of having to have private tunnels and APNs and VPN connections on a lot of devices is a thing of the past. I mean, I'm doing banking on this device through the public APN. The encryption and security lies elsewhere, not in the tunnel. So, you know, the public APN is still a very reliable option. And on this, prepaid is one option. Also great for projects where you are unsure around the volume of SIMs that you're going to deploy or the period of SIMs that you are deploying. It gives you a lot of options around easy deployment and easy sort of suspension of SIMs, and that way managing your costs. It also, you know, is quite good in terms of cost control. There's no risk of bill shock or credit risk. Low data costs, especially on the high-end usage. We find that, you know, prepaid data costs, especially in the larger bundles, is very competitive. The downside, of course, that you cannot do any custom data routing, firewalling, VPN type stuff. So data is data. internet is internet, which is fine for many applications. But if you need specific data routing or firewalling or that sort of infrastructure, then that is definitely not the best option to go for. Secondly, looking at sort of business top-up. These are, call it standard data contracts that called top-up or hybrid type contracts. Find very competitive data here. So for very large data applications, cheaper data, but not much control. Although there is some monitoring that can be done in terms of balance monitoring and recharging SIMs when they actually use up their allocated data bundles, that can be automated. So often the drive for this option would be around data costs. You do need to commit for long-term contracts. And again, running on the public APN, you don't have the option around custom data routing or firewalling. Then moving on to managed APN environment. So this is where a lot of customization can take place in terms of setting up specific APNs that has a lot more, where you have a lot more control over the SIMs and the data. Here we're looking at a fully managed APN as a service. So you basically have two options. You either can get an APN directly with each telco and then manage that yourself to manage the networking and radius and everything yourself, or you can look at APN as a service. In terms of the sort of managed APN environment, some of the advantages will be able to run multiple network SIMs on a single APN. So you can actually deploy SIMs from two network. In this case, in South Africa, it's either Vodacom and MTN. And also one of the benefits would be data pooling across both those networks. So a central pool where SIMs from both networks would feed off. There are lots of options here around firewalling and data routing, so setting up VPN connections and also blocking certain traffic or only allowing traffic to go to certain IP destination IP addresses. That is all possible on a managed APN infrastructure. And then also SIM IP management. So if you need specific fixed IP ranges, for example, on SIMs, then that cannot be done on the public APN, and you're forced to go the managed APN route. The important thing about going the APN route is that you need to be able to manage what the SIM consumes. So having pooled data and not having a tool that actually can see exactly which SIM is consuming data and stop that SIM immediately when it starts reaching its cap is quite dangerous. You don't have the control over it then. So SIM level quotas and reporting around which SIMs are consuming what becomes critical when launching APN SIMs at scale. For a managed APN, you need a base contract from the telco, so typically a M2M or APN type contract. So a lot of benefits here, a lot of options, but often that comes with a cost. So you find that data costs, although at larger sort of bundles, it comes down to about, I think, 8 cents a meg roughly. You can get some data at scale, but obviously APN data can be more expensive on the bigger bundles than, for example, business prepaid. And also, with complexity comes risk. So the more complicated your connectivity solution becomes, the more points of failure there could be, the more complicated the whole network infrastructure becomes. So, advice often from our side would be to try and find the simplest connectivity solution that ticks the boxes that you need for your specific project. So more complicated is not always better in connectivity land. In fact, keeping it simple has a lot of benefits. But depending on your solution architecture and the way that your solution is built and the requirements that you have there, sometimes you're forced to add complexity to your connectivity solution, and then it becomes important to be able to manage that properly. And that is sort of where our experience comes in. Another SIM option to look at for devices would be global roaming SIMs. These are SIMs that can roam across countries and also in specific countries roam across networks. So most roaming SIMs would allow at least 2 networks per country that the SIMs can connect to. So one of the benefits there would be that you actually benefit from the coverage of both networks, and depending on which country in that can be quite a large benefit. In South Africa, not so much, because the 2 biggest networks have relatively similar coverage areas. But if you look at some other African countries, sometimes you find that certain networks are much stronger in certain regions. Fairly easy deployment. SIMs can be inserted and tested in devices and then shipped to the other country. So it's fairly easy to test and deploy. There are many roaming options out there. The big sort of question here is that, you know, not all roaming SIMs are optimized for certain regions. So you find SIMs that are really optimized for roaming, for example, in the Americas. Then you get other SIMs in Europe, other SIMs in the East, and you know, doesn't matter what the brochure says in practice, not all SIMs are optimized specifically for African roaming. And there the issue typically could be that there is latency issues. Just on a technical levels, the SIMs just don't perform as they should. So every roaming SIM has got a network of partners and roaming partners, and you know, not all roaming SIMs perform the same in the field. Doesn't matter what the brochure says. So that's just an important thing, and where sort of we come in, because we are network agnostic and we deal with a range of roaming partners. Depending on where you are deploying to, we can also help you advise from actual experience which SIMs will perform. And we also allow our customers to test different roaming SIMs on specific routes. Let's say you are doing logistics routing through specific African countries. We can help you to test the different roaming SIMs to make sure that you are comfortable with specific countries that you're visiting from a performance, you know, level, and then also from a cost perspective, because roaming data can be very expensive. So there are really quite a wide range of data pricing depending on which regions you're going in, and sometimes it can break the business model. So yeah, it's quite important then to, when looking at roaming SIMs, to look at what the different options are, look at the technical stability, the quality of the connectivity, as well as the cost, and then try and make a sensible decision over there. Very important when doing roaming to have real-time visibility around cost, not just visibility, but also real-time locks around spend. The last thing you want to do is have a SIM that just connects on specific networks and you are saddled with bill shock at the end of the month. So when it comes to global roaming, the real-time visibility and control becomes really important. Now, those were the different SIM types, general SIM types that you can look at with cellular connectivity. I'd like to touch on choosing your networks. And here, you know, so many options out there, and it's often driven by sentiment, but you know, a few things sort of ring true. And the one is a thing that we've learned over the years is also, you know, you sort of get what you pay for. So if you are making decisions purely based on data cost, you might not be making the right decisions. So data cost is definitely one aspect to consider when choosing different networks, but it's definitely not the only one. So you know, it's quite important to get that balance right, and when looking at different types, different network options, to understand what they offer and not just to look at the cost side. The quality of networks also differ, and this is typically related to how much they invest in their network. So you'll find that every country has got some sentiment around that, and sometimes it's just opinion and sometimes it's sort of more factual, but yeah, typically some networks do invest more in their technical infrastructure, and although they might be slightly more expensive, it could be a better option for you if you're looking for reliability for IoT connectivity. So a few things here to look out for, just to be careful for long-term contract lock-in. Now, at some stage, you need to commit for certain things, but especially when you're looking at APN data, it's tricky, especially if you're starting to roll out the IoT project, to predict exactly how much data you're going to use when. So I think flexibility here is crucial, not committing for certain amount of data for a long period of time, because you don't know if you're going to overshoot or undershoot. It's very hard to predict. You also can have out of bundle risk on some of those agreements. So if you don't use the data, it expires. If you do use it and go over, you get billed for out of bundle. So just understanding all the costs and risks around that is quite important. Very important to get real-time visibility over not just your consumption, but your actual spend, both of those, it's quite risky to look at solutions where you've got no idea what your costs are until you get the bill in the following month. Those days are sort of over. There are enough tools to give you visibility. And then, yeah, roaming, I mentioned that. Look at reliability, look at latency, look at data costs. Those are key aspects to look at when considering roaming networks. And then reporting, you need to understand what drives your costs. You also need to identify problems easily. And as you scale, as you deploy more SIMs, this becomes harder and harder. And, you know, networks are great mobile networks and they deliver great connectivity. They don't always have the tools to give you this level of control. So depending on what type of solution you have, you'll have less or more visibility and control over what you're spending. And also, I mean, it's not just about spend, it's also just identifying problems, identifying SIMs that are not being used, for example, that you don't need to pay for, identifying SIMs that are using too little or too much data, those sort of things. And then the next point's really around, you know, dealing with multiple networks can become quite tricky. And like I said right in the beginning, a lot of IoT companies end up dealing with different types of SIMs on different networks. So that can become quite a complex relationship to manage, because you need to now manage different relationships into different networks, and all with different tooling. So it becomes quite tricky. So one central point of control becomes a big benefit when you are starting to deploy different SIMs from different networks. Another thing when choosing your network is to really try before you buy. SIMs and solutions don't always perform exactly how they are sold. So very important to actually test properly, deploy different types of SIMs, weigh SIMs up against each other. Once you've decided what type of SIM is to maybe look at which network works the best for you. So that's an important fact when looking at any solution, especially during POC phase, to try different SIMs, try different networks, and to really understand what works best for you. Longevity of networks is important. I think the Sigfox example has been a bit of a wake-up call for the industry as a whole, to make sure that you are choosing networks that have financial stability in terms of their business case and that have longevity. Like I said, changing ways of connecting is pretty tricky once you've started rolling out. So that financial investment is important. And lastly, a point that is sometimes overlooked in terms of the SIMs that you are deploying is that it's important to retain ownership of SIMs that you are deploying, like you are retaining ownership of your hardware or your software. In a way, the SIM is also important. So there are some SIM offerings out there that actually, where you don't actually own the SIM. These are typically offered by ISPs, fiber ISPs, for example, which are more aimed at the consumer market, where it's not that important for the actual end consumer to really own the SIM. So a quick test of that is, if you are receiving the bill from the network for the base contract fee, then you are the owner. If you are not receiving that, then you are probably not. So just an important fact, because you need that strategically, you need ownership of the SIM, because that gives you options. It gives you options to switch between, you know, providers, for example, and it allows you to then, being the owner of the SIM, to not be held ransom by anyone else in terms of who owns the SIM. So those are just some general comments around choosing your network. At the end of the day, there's quite a lot of opinions, especially on local networks, but luckily in South Africa, we've got, you know, 2 solid networks that have strong IoT histories. That's great. Some African countries that we operate in, you don't have that option, so you only have one sort of dominant player. So yeah, that comes down to opinion at the end of the day. Yeah, just in terms of where SIMcontrol fits in, this is our network agnostic SIM management platform focusing on IoT machine-to-machine connectivity. So we are basically a service layer between the network and the customer, where we offer additional services in terms of managing SIMs better at scale. And why are we network agnostic? Because we want to give people different options. We don't want to just resell an existing telco product, but we want to to give customers different options around different projects so that they can look at different SIM types and also look at different networks that they prefer. If for those of you who haven't used SIMcontrol before, it's basically an online platform where you can manage large number of SIM cards on one single platform. I've already gone through the different SIM types that we offer, and it basically gives you control and reporting over your SIMs. We also do bulk SIM supply, activation, and network provisioning. And yeah, the other aspect which is often overlooked is just the support aspect. So when it comes to IoT SIMs, they're very specific type of things that you can do from a troubleshooting, reporting, and support point of view. So the sort of standard answer of please reboot your device won't fly in most applications. And yeah, this is where we've got, over 10 years experience in terms of IoT SIMs and the problems that those specific SIMs may encounter. Not going to go through all the features, but just touching on basically giving you flexibility around contracts, reporting and data insights. We've got an advanced API that you can use to integrate data from different SIMs on different networks into your business processes or platforms. And then, like I said, we also do the support and some supply side of things. Our presence in Africa extends to Zambia, Namibia, South Africa, Zimbabwe, Mozambique, and then Tanzania and Kenya, either through partners or our own offices. And then we also offer 3 different roaming networks that covers many networks globally. And all of those are integrated into the same SIMcontrol platform. Try before you buy. For those of you that'd like to try any of the sort of SIM connectivity options that we mentioned today, please visit us and speak to us, and we can help and assist you to make the right decision. All right, thank you very much. Ishil, over to you.
Yeah, thank you very much, Hein. It was a nice webinar. We will go ahead and take some time for questions now. If you have any questions, please be sure to type your questions into the question box in your control panel. Yeah, we have, looks like we have a question. Yeah, hello, Hein. If you start a business with multiple SIMs that belong to you, are recorded in your name, for example, are recorded in your name, where does your liability end if the SIM is removed from the device?
Yeah, good question, and one we receive quite often. So I'm not going to give you a legal answer, and then give you a practical, because you can go and read the law, the RICA law. The one thing about the RICA law is it's very light on IoT. It was written before it was even a term that was used, so it focuses a lot on consumer type devices. But from a practical point of view, SIMs that are owned by companies, that are used by companies in their solutions, they are RICA'd in the company name. It's legally registered. We actually assist companies with getting that registration done. The company then owns the SIM, and depending on the type of solution that you're offering, sometimes you will need to keep record of the way you are deploying a device to, and depending how it is used. So, but typically IoT applications, the SIM cards are the company's property. It's registered in the company's name, and it's deployed in various devices, not to a specific end user, as is the case in consumer devices. So yeah, that is on a practical level how it works. Obviously, you need to work closely with the mobile networks. You can't just walk into a shop and order 1,000 SIMs and say it's for IoT. So we can assist you with the RICA processes for the different telcos to make sure that those SIMs are properly registered.
Thank you. And we have another question. Tell us more about the Keep Alive function.
Okay, I think this is relating to prepaid SIMs that they're mentioning. So every type of SIM that you deploy has got different network rules, basically. So these are rules that the network enforce in terms of SIMs and how long they keep them active on the network, for example. So for every SIM type, you really need to understand what the different rules are. So for a specific contract SIM, there'll be certain conditions attached to your contract in terms of paying your monthly fee and the SIM staying active. And then in prepaid land, every network has got their own conditions in terms of when SIMs, how much sort of usage a SIM needs to be able to stay active on the network. So again, this is something that we can help you with, depending on the network and how they manage that, how their rules are. our platform can also help you recharge SIMs automatically to make sure that they keep alive. That's where the keep alive question comes from, and they don't get deleted by the network. As an example, a network might see a SIM that has had no recharges onto a SIM for a certain period of time, say 90 days. It might flag that SIM as a SIM that is not being used on the network, and it might actually delete the SIM from the network. So when deploying different SIMs, you need to really understand what all the different keep alive, how are SIMs kept alive by the network, whether it's roaming SIMs or contract SIMs or prepaid SIMs, to understand what the conditions are around keeping a SIM active on the network. And we've over the years developed functionality in our platform that will actually make sure that SIMs are kept alive by triggering certain recharges, making sure they spend on that SIM that complies with the telco's rules. In that sense. But it's a very important factor. It's something that needs to be kept in mind when choosing different SIM types. For example, if you've got devices that's going to be lying on a shelf for many months, you might make a different decision than a device that you know is going to get used every day, for example.
Thank you. Another question about NB-IoT. For NB-IoT, apparently we need to use separate Vodacom SIMs. Can we get these SIMs through you?
Yeah, so NB-IoT actually runs in the LTE spectrum. So the physical SIMs are exactly the same SIMs. Those SIMs just need to be provisioned specifically for NB-IoT. So it's not a different physical SIM, but it is SIMs that need to be provisioned in a very specific way for them to work on NB-IoT. And yes, the process is typically that the NB-IoT is activated on the APN that you use. So in our case, it'll be through the managed APN, which is NB-IoT enabled. And once those SIMs are put on our APN, we identify them as NB-IoT SIMs, and they are provisioned in a specific way with the telco as well, and with us, with our APN. There's also very specific IP ranges that the NB-IoT SIMs operate in. So it does get slightly more technical. You can't just take a normal SIM, pop it in and connect on NB-IoT. There's some provisioning that needs to happen there. Yes, we've got a number of customers that are testing at the moment, and it's still early days in NB-IoT land, but I think especially with some of the solutions that were using Sigfox are starting to look at alternative options, and NB-IoT would be an obvious one. So there's quite a lot of interest at the moment. But yes, we can help you if you contact our team through the website, they'll be able to explain exactly how that works.
There is another related question about LTE Cat M1. I think it's somebody rolling out LTE Cat M1.
Yes. So that is also a type of NB-IoT or low power WAN, and there are basically two flavors of LPWAN that telcos are deploying globally. Some networks are going the NB-IoT route and some of the Cat M1 route. So depending on the network, they will have different specific spectrums that they are deploying the LPWAN on. Actually, it'll on the help desk solution link that we've got quite a nice article on the different options around that. So maybe if you can just get that name, I will reply after this, or pop us a link through the website and just ask us for a link for the article explaining Vodacom spectrum, exactly which flavor of NB-IoT they are using, and then also in the country they're using different spectrums in different parts of the country. Doesn't mean you need different devices, but the devices will connect on different spectrums, but there's quite a nice map and explanation on that. So yes, every network that is rolling out LPWAN is rolling out a different flavor of that, and you must make sure that the module that your device is using is compatible with the type of LPWAN that they are rolling out.
Okay, I will share the information with you. Another question about restricted and unrestricted SIMs. What are the differences between restricted and unrestricted SIMs?
Sure. So in the early days of IoT, the networks made available APN called the Unrestricted APN, which basically removed all the port filtering and any sort of clever firewalling on those specific SIMs. So it was an APN that was really open and quite risky in a way, because they took away a lot of the security, and they only made that available for specific SIMs, not just normal consumer SIMs, but these would typically be things like CCTV cameras or also devices. What that APN did, it actually gave the SIM a real IP address, so an IP address that can be reached from the outside. Mostly any other SIM that connects on the public APN just gets a NATed or a local IP address from the tower. So on the unrestricted APN, the SIMs would get a real IP address, although it's not fixed, it would be reachable, and there would also not be any restrictions in terms of ports and everything. Those APNs have been mostly, although they're still active, they're not accepting any new SIMs, so they may being sunset in terms of not accepting new SIMs on those APNs. So your best alternative would be to look at a managed APN functionality, where the reason why you would need unrestricted APN would typically be something like getting a fixed IP address or having specific ports opened for specific use cases. And that can be achieved on a managed APN, where specific custom networking can be set up to allow your SIMs to access those specific ports or to get a fixed IP. So it's a bit of a legacy infrastructure that is still there, but unfortunately the telcos are not allowing new SIMs to be connected on that specific APN. I hope that gives a good enough answer.
Yeah, exactly. So we have a question about managed APN. I need to access a router remotely. I currently have a telecom SIM in it with an unrestricted APN profile set up, but the connection is not reliable. Will a managed APN service be of use to me?
Okay, so I actually talked to Fib, because I think Telkom's normal public APN also did similar to unrestricted APN, and they're still active in terms of allowing an unrestricted APN. I think it's the last network that still allows that. But yes, unfortunately with Telkom, they are either have their own network or they are roaming on Vodacom, and I suspect, and I'm guessing here, that your issues could be that APN only works on the core Telkom network and not through the roaming partner. So again here, it's a bit of a, when it comes to sort of selecting networks, Telkom would be good for certain types of applications, and others, because they are roaming on Vodacom, if they don't have their own core network coverage, might give you some issues in that regard. So the short answer is yes, you could look at a managed APN from either Vodacom or MTN, and that you should be able to achieve what you want to achieve. But there's a couple of questions. Firstly, like going the managed APN route is not for a handful of SIMs. You need at least some volume to make that all a viable exercise. So depending on the SIM volume, but that's something that our team can help you with. So please just pop us on the contact form on the website, just pop your inquiry, and they'll be able to help you in terms of what other options there are, because you have to look at sort of what data you're using, how many SIMs you've got, to see what other options there are.
Yes, our website is simcontrol.za. You can see the contact form here. And we have two more questions.
Yeah.
Roaming across African countries, what are the typical issues that you encounter?
Yeah, so it's a good question. Roaming between countries, especially in Africa, is not something that you can be guaranteed connectivity 100% of the time. I think two things there to look out for. Firstly, which roaming provider you are choosing is very important. Some roaming partners have a long history in Africa and much better technical infrastructure. They've got points of presence in Africa. The way that the data flows from the SIM to your server takes a much shorter route than some others that will bounce around the globe 20 times before it breaks out to the internet or gets to your server. So I think firstly is, reliability is very important, and there are definitely, we see that some SIMs perform much better than others in terms of African roaming. Some SIMs have got a much longer history with local networks, so they're much closer to the local network. So a practical example is that roaming between the roaming network and a country like Swaziland, for example, goes down. Now, For some roaming providers, that would be very, very low on their list to attend to. From an importance point of view, if they're not focused on Africa, that could take a very long time to resolve. While some roaming networks have got, for example, direct relationships with the local networks, and if there's a break in roaming connectivity, it is attended to much quicker. So that's the sort of one level. The other level is that you are still dealing with local networks. So your roaming is only as good as the local network is. And yes, you have the benefit in most countries that SIMs can connect to multiple networks, but still they do find that infrastructure problems does affect, in the same way that load shedding affects our connectivity locally here, you get the same in other African countries where there's all kinds of different infrastructure problems that sometimes don't make the local networks as reliable as they are in South Africa. So that's the sort of other thing to look at, is so which global roaming provider, and then also obviously there are some local issues that you have to sort of make peace with depending on the type of device that you're rolling out, the application. For example, we've got some customers who do lots of high value shipments in terms of tracking and those sort of things, and there they would actually look at either 2 devices or dual SIM devices to actually, with 2 roaming SIMs in, to actually, you know, give them a bit of fallback and redundancy in that regard. But yeah, that's typically an option. But you know, also testing your countries and your routes properly, so making sure that the provider you have do it in real life, send a device out, test it in real life, see how it performs. That is pretty important. But you know, roaming has become quite a bit more controllable. We, through our platform as well, you can see a lot of information, like for example, the last session data and those sort of things. So you've got some tools to at least troubleshoot devices. And thirdly, you've got a way to manage your cost, which, you know, a few years ago was very, very difficult, where you deployed a SIM and just hoped for the best and waited for the bill to arrive at the end of the month. So those days are over. You now have, you know, visibility around your cost and your technical, you know, some technical troubleshooting data coming through, plus you've got control over your costs in a real-time fashion, and those 2 things are very important.
And we just prepared a brochure on, like you can see on our website, about global roaming. And last question, can you give me information about the prepaid option? How does it work with IoT?
Yeah, so I mean, it's just a different SIM type. So depending on the type of deployment, it could be quite a good option for you. We're finding, especially where you need to be quite flexible in your deployment, so where you don't want to be tied into long periods. Let's say you're doing a 6-month project on something, you don't want to be locked into long-term contracts. That very popular for that. Also, the data costs on the larger bundles are very good. So if you're looking at sort of video type stuff, media, a lot of the high, which is not typically sort of low data IoT type applications, those also are very popular with prepaid, and sometimes the low data stuff as well. It depends on, again, on your you know, what your factors are when you're deploying out, what your use case is. And it could be, you know, it's also a very cost effective way of doing it. So if cost is a big factor for you, then it could be a good option. So, you know, there's no one SIM that we discussed today that is better than the others. I think it really depends on matching your use case, your requirement to the best SIM. And again, just maybe a last point to make, trying to keep it as simple as possible, because the more complexity you start adding, then, you know, the harder it becomes to manage at scale. So that's maybe a good thought to leave with everyone today.
Yeah, I was thinking that, but we had another question.
Quick one, we've got 10 seconds.
It's possible to use dynamic DNS on prepaid SIMs, or to be able to connect externally to the modem?
Yeah, so you get so on prepaid SIMs, you actually get an IP issued by the tower. It's usually netted. It's not a real IP. So you can use stuff like DIN DNS and those sort of things, but the IP that you're going to get on the SIM is not a publicly accessible IP or a privately accessible IP. It's actually from the tower. So yeah, it could work well if you've got a way to manage that. It's very successful. We've got prepaid SIMs deployed in all kinds of IoT devices, from credit card terminals, tracking units, all applications. And it depends on the architecture of your solution and whether it can use that. If it's happy to use public internet, and you're happy it can use an IP address that gets allocated by the network that can change every time the device reboots, or if it connects to a different tower, then it could be a good option for you. But yeah, we can also help you talk through the options there.
Perfect. I think it looks like we covered all the questions. Hein, is there anything else you wanted to cover before I wrap up?
Yeah, just the last thing. I mean, yeah, it can sound like a bit of a minefield, especially if you're new to this game. But yeah, please come and talk to us and try before you buy. Try, make sure that you test different options, and then you've got confidence to decide that the SIM type that you're choosing and the network that you're choosing is the best one for your specific solution.
Okay, great.
Thank you.
Thank you, everyone. We appreciate you being here, Hein, and thanks again for joining us today. We will see you next time then.
All the best. Thank you.
Thank you. Bye.